New York is sinking. Right now, as you're watching this, parts of New York City are dropping by up to 2 millimeters every year. That might sound small, but multiply that across over 1 million buildings, weighing nearly 1.7 trillion pounds. And suddenly, the ground beneath one of the most powerful cities on Earth is slowly giving way. This isn't just about land. It's about subways flooding, foundations cracking, entire neighborhoods becoming unlivable. Over 8 million people live here. Wall Street, critical infrastructure, hospitals, transit systems. If this continues, we're not talking about inconvenience. We're talking about billions in damage and a city that may not be able to hold itself up anymore.
But here's the real question. Is New York just experiencing natural settling? Or is this the beginning of something far worse? Something that can't be stopped anymore? To understand what's happening, you have to go back. Thousands of years ago, this entire region was buried under massive glaciers. When those glaciers melted, they left behind a complicated foundation. Some areas, solid bedrock. Others, soft, unstable sediment. Fast forward to today. On top of that uneven ground, we built one of the densest, heaviest urban environments in human history, especially in places like Manhattan, where skyscrapers don't just sit on the land, they press into it. Recent research shows that New York's buildings alone weigh around 1.7 trillion pounds. That's like stacking thousands of mountains onto a surface that was never meant to carry that load. And the result? The ground isn't just holding steady, it's compressing. Slowly, unevenly, relentlessly. In some areas, the land is sinking faster than others, creating tiny shifts, tiny distortions. But over time, those tiny shifts turn into structural stress. Cracks, leaks, weak points. Imagine placing a glass on a soft mattress. At first, nothing happens, but leave it there long enough and the surface dips. Now imagine that on a scale large enough to cover an entire city skyline. That's New York, sinking millimeter by millimeter. And here's where it gets worse, because the ground sinking isn't the only problem. At the same time New York is going down, the ocean is coming up. Sea levels along the East Coast are rising faster than the global average. Why? Warming oceans, melting ice sheets, shifting ocean currents. This creates a dangerous combination. The land sinks while the water rises. A double impact, a slow-motion collision. It's like lowering a city into a bathtub while simultaneously filling it with water. Eventually, something gets submerged. Scientists from organizations like the United States Geological Survey and climate researchers across the US have been tracking this for years. Using satellite data, ground sensors, advanced modeling, and the conclusion is becoming harder to ignore. Parts of New York are not just vulnerable, they are actively destabilizing.
This isn't happening in some distant future. It's already affecting real people. Flooding during storms is becoming more frequent. Basements fill with water. Subway tunnels, some over a century old, are under increasing pressure. Businesses shut down temporarily. Repairs get more expensive. Insurance rates rise. And in some areas, people are quietly starting to ask a question no one wants to say out loud. How long can we actually stay here? Because if this trend continues, this doesn't stay a local problem. New York's infrastructure was never designed for this. Many systems were built decades ago for a different climate, a different coastline, a different reality. Now, engineers are facing a moving target, not just rising water, but shifting ground beneath critical structures. Bridges, tunnels, foundations, even slight movement can create stress in systems that depend on precision.
So what are they doing about it? There have been attempts: massive flood barriers, storm surge defenses, drainage upgrades, projects costing billions of dollars. But here's the problem. Most of these solutions focus on keeping water out, not stopping the land from sinking. And you can't just fix the weight of an entire city. You can't remove millions of buildings. You can't reverse gravity. So the question becomes, are we trying to solve the wrong problem? Because when land sinks unevenly, it doesn't just lower everything uniformly. It creates differential movement. Some areas drop faster, others stay stable. That difference, even if it's just millimeters, can stress structures in unpredictable ways. Over time, that leads to failure points. And failure points in a city like New York don't stay isolated, they cascade. Think of it like a massive table with uneven legs. At first, it just wobbles, but keep adding weight, and eventually, something snaps. Now imagine living above that, commuting through it, relying on it every single day. For millions of people, this isn't theory, it's their reality. And most of them don't even realize it's happening beneath their feet. But here's the part that keeps scientists up at night: the combination effect. Sinking land, rising seas, more intense storms, each one alone is manageable. Together, they create a system that becomes harder and harder to control. A tipping point, not a sudden collapse, but a gradual shift, until one day the damage is no longer reversible. New York isn't disappearing overnight, not tomorrow, not next year, but the process has already begun. The ground is moving, the water is rising, and the city is adapting as fast as it can. But here's the question no one can fully answer. When does adaptation stop being enough and turn into a race that can't be won?